Alright, thank you for joining me today. I'm going to be talking to you about how to identify dependent and independent variables. Alright, so let's go ahead and take a look at a couple terms here real quick. Make sure you're familiar with what a dependent variable and independent variable are. First of all, a dependent variable is represented on the y-axis of a graph. So if we're talking about an x and y-axis, alright, the y-axis is your vertical axis, and then your x-axis is your horizontal. Okay, so the dependent variable is always represented on the y side, okay, right here. And then when you're looking at graphing, the independent variable is always down here along the x-axis. Okay, and they're named because they are exactly what they say they are. The dependent variable depends on something, and that is typically going to be the independent variable. We'll talk a bit more about that in a moment. Alright, and also a function. Okay, we use independent and dependent variables in functions, and these are simply just relationships between a set of inputs and outputs. So for instance, one that you're probably most familiar with would be like a vending machine. When you press a particular button on the vending machine, something comes out. Your input is pressing the button, the output is what you're supposed to get. Alright, so let's take a look at how we can identify these. Typically you're going to see problems that involve tables such as this, okay? And these tables can use different variables. You're probably used to seeing them using x and y, okay? And that representation doesn't change a whole lot unless they're trying to trick you, really, and I don't typically see that. Usually you will always have the x variable on the left and the y variable on the right. So having said that, what they're going to ask of you here is to determine which of these is your independent and dependent. Well, if you remember what I just mentioned a moment ago, that your dependent variable is always going to be along your y-axis and your independent variable is always along your x-axis. Well, again, you kind of already know that because the order doesn't change a whole lot. So in this case, you can see if we're going to write an equation here, your cost is going to be equal to the number of, in this case, soccer balls multiplied by n. Okay, and I'll explain why it's written that way. First of all, total cost is always going to be dependent upon how much you buy. Okay, that is a typical question asked. Total cost as well as time. Time is another one you can remember as always being independent. Okay, so in this case, total cost is going to be equal to 18n because, as you can see here, every time you multiply 18 times whatever n is, you're going to get a value. In this case, how much it would cost. So 18 times 1 is going to give you $18 if you purchase one ball. 18 times 2, all right, is going to give you, in this case, 36. That makes your total cost go up by 18. So you can see that the total cost in this case is dependent on how many you purchase. So n, in this case, is your independent, and c would be your dependent. Okay, so let's take a look at another one here. Alright, same situation. This time they actually label them x and y, and that typically is going to make it easier. But you can see, in this case, you're talking about the number of hours worked at a job and the total amount made. So again, you're talking about a total amount, similar to total cost. So the total amount, again, is going to be dependent on the number of hours that you work, and that's going to be x in this case. So you can see as the number of hours go up, the total amount that you get paid goes up. Okay, and it's a consistent, what we call linear relationship. So in this case, y is going to be equal to the x value multiplied by the y value. So 850, or the number of hours that you work. There you go. So 850x in this case, and then you would just simply substitute in your x values here and multiply, and you'll see that you will get these values to the right. So let me clear that off and explain one more time here. These values here in the x column are going to be what ultimately are going to be dependent on the y. So let's see. Y equals 850 times x. Just like that. So like I said, you can plug in your x values, substitute them in right here, and should give you the corresponding y value. So notice when I do the math here for the second one, it would be y equals 850 times 2. 850 times 2, you can do the math, 850, and you'll see that it does end up giving you $17 when you do the scratch work real quickly. So in this case, you can see X is your independent variable and Y is your dependent variable, because the total amount that you make is going to depend directly on how many hours you work. All right. And this also is represented in graphs, and a lot of time the graphs are a little bit easier for students to read. Again, because your independent variable is always going to run along the bottom, and your dependent is always going to run, sorry, I'll mark that, there you go, your independent down here, and your dependent is always going to run along the side there, which is your y-axis. So in this case, they're asking you to determine which is the independent and dependent variable. Well, we've kind of already done that, because hours is always going to be independent. Time will always be independent, and that is because basically time doesn't wait for anything, okay? So ultimately time will always be along that x-axis, and so that means that the D dollars in this case is going to be your dependent. All right, so in this case the second question would be how much was made after 4 hours of work. Well, what you can do here is come out to where you worked 4 hours, which would be right here, and then shoot directly up your graph, and wherever the line meets is going to be your solution. So you can see here, because the line meets at that particular point, whatever corresponding value to the left is going to be your answer. So in this case, it will be $60. All right. So to conclude this slide, we figured out that H hours is your independent variable. D dollars was your dependent variable. And again, that's because the amount of money depends on how many hours. So in this case, looking at our graph, we could see after 4 hours, we end up at $60. All right, so let's look at one more. Another graph here. This one's dealing with miles traveled, and again, you can see time is related here in hours once more. Time is a very popular independent variable for what I mentioned before, the fact that time doesn't stop and doesn't depend on anything. It's going to continue no matter what. So in this case, hours is our independent, miles traveled will be our dependent, because the number of miles that we travel is going to be dependent on how long we travel. So the second question here is how far have they traveled after 3 hours? So again, find 3 at the bottom of your graph, follow that line on the grid straight up, and where it meets your line, go directly to the left to the y-axis and see the corresponding value. In this case, it's 210 miles. So after 3 hours, we'll have traveled 210 miles. This has been a quick tutorial on dependent and independent variable. Thank you for joining me.